Hello and welcome to my talk about lunar eclipses. It's a talk I've prepared for an open evening at the Norman Lockyer Observatory, which has many open days and evenings throughout the year. You're very welcome to join us and become a member yourself. As a member and volunteer, you get to use the historic 19th century telescopes, which are all in good working order. Sir Norman himself, Sir Norman Lockyer, was a great Victorian scientist, best known for his discovery of helium, but he was so much more than that. I've been privileged to carry out some research on some archive files held at Exeter University, and the more I'm researching, the more there is to learn and find. He was interested in anything and everything in meticulous detail. So there's so much to learn about him, and he's not such a well-known scientist, so I'm working hard to promote that as well. But for this talk I'm going to talk about lunar eclipses, but first I'm going to say a little bit about the moon as it normally appears to provide context for explaining lunar eclipses. You're familiar with the phase sequence going from a very thin crescent. You might be lucky enough to see the eyelash size crescent before it gets bigger and becomes full. So to have a full moon, you've got to have the sun shining directly at it with nothing in the way. Slightly out of order, talk about solar eclipses here. For a solar eclipse to happen, the moon has got to be in the way of the sun so that we can't see the sun from the moon. So the moon is facing us with the same side each time. So when it goes through all these phases, it's just the angle of the sunlight on it. So half the moon will always be lit, but we don't see the lit half all the time. There is no dark side of the moon, only the far side, and it's this far side that is lit when we don't see it. So when we see half a moon, from our perspective, it's actually a quarter lit because it's a sphere, and the other part of that half is facing away from us, so we only see the bits from our angle. So it's all to do with angles. The moon does orbit very slowly. It takes around 28 days. There are various cycles of the moon's orbit, but essentially 28 days is enough you need to know to understand its orbit. I'm going to explain more about the orbital tilt in the next slide, but suffice to say we are orbiting on a fairly level plane around the sun, and the moon is at an angle to that. And I'm just going to run this video. Oh, no, I'm not. The video didn't work last time I recorded this, so I'm going to include a link on my YouTube page for you to look at this. But basically you see the moon going round, and you can see that the lit half is different from where you are standing on Earth. I find it very difficult to do these things without using my hands, but please play the video. I'll put a link in, and then you can see why you only see part of the lit side as it goes around the Earth. And look at what the Earth is doing. The Earth is spinning like a gyroscope. It's wobbling and tilting, and the moon is at an angle, and we're all orbiting the sun. So that's why it is a complex thing to get your head around. So when you look at the moon, look at it with renewed respect. So going back to a solar eclipse, while we're on this slide, do not ever look at the sun directly. It will blind you. So solar eclipses are more common, but they are very fast. They are fast and dangerous, and it takes just a few minutes for a solar eclipse to occur because the moon is so small. Conversely, because the moon is moving slowly, you have more opportunity to enjoy a lunar eclipse. So they're slower and safer, and they take about a couple of hours. As I say, first of all, I should explain about the orbital tilt. But before going on to that, what does a lunar eclipse look like? Well, this was taken 18 years ago, and you'll hear me mention 18 years again. They occur sort of in clusters because of this orbit, but you can see in this photograph the top of the moon is not lit, and that's because the Earth is in the way of the sunlight shining on that full moon. So for a lunar eclipse to happen, it has to be a full moon, because the sun needs to shine directly on it, and then the Earth needs to be in the way of the moon and the sun. Now, lunar standstill is when the moon reaches the highest or lowest point on its orbital tilt before tilting back again. When I give this talk live, I use a hula hoop to demonstrate that orbit going up and down within a range of about 5 degrees. Again, the next video link I will include will show this much more clearly than words can. It's very difficult to describe, and I think it even drove Isaac Newton mad trying to get his head around what the moon was doing. But the next slide will show, or the video rather, so do click on the next video link and you will see what the moon's orbit is doing much more clearly. So this diagram, the blue is the Earth and the white line around it is the moon. So when you press play, that white line, the whole image will turn sideways, so you can see the angle of that 5-degree tilt. So it doesn't go more than that, but the whole orbit goes down and up again over a period of 18 or so years. So my photograph in the previous slide was taken about 18 years ago, so we're coming up to another lunar standstill, and there are lots of events at Stonehenge at the end of the year through to April to look out for. So what are they? Exactly. Here's a nice diagram from an old astronomy book, and I chose this because it's a sort of book that might have been on Sir Norman's bookshelf. It's from a popular Atlas of a Popular Astronomy in 1903 by someone called Thomas Heath. And this diagram shows the moon moving from the lighter part of the shadow into the full dark of the eclipse at its peak. So the sun is coming from the left in this diagram, the Earth is in the way, and the moon is in shadow. So wherever you are on that half of the Earth, facing the moon, you will see a lunar eclipse. Why can you still see the moon though? Well, sunlight is still lighting up the moon through the effects of refraction. This is when the Earth's atmosphere bends light from the sun towards the moon. Put simply, light is travelling in a straight line, but when it meets an object, slows down, changes direction, before continuing on the same straight line as before. The colours of the moon are dependent on what is happening in the Earth's atmosphere. Recently there's been a reddish moons because of the wildfires in Canada. All the ash from that has gone up into the atmosphere, and it's through that lens that we're looking at the moon. We're looking through the Earth's atmosphere at the moon. So it's like having a net curtain that you're looking through at the moon. So what's happening on the moon while all this is going on? Well, you get a total solar eclipse because the Earth is blocking the sun from the moon. And with there no atmosphere on the moon, the lunar surface is cold anyway, but the eclipse shadow makes it colder, the temperature dropping by a few hundred degrees. So during an eclipse, both sides of the moon are about the same temperature. Normally one half will be very, very hot and the other very, very cold. But obviously with no sunlight on it, it'll all be similar. So there's another diagram here, it's a simpler one. M1, M2, M3 show the position of the moon as it's moving through the dark shadow into the lighter one again. So basically it's refraction in action, the moon passing through all this on its orbit. And as I say, it takes around 2.5 hours for it to go through. So that's a very clear diagram of the light coming from the sun, going around the Earth and then meeting the other side of the moon, which is why it's a cone shape. And here is a nice sequence taken by one of our young observers back in 2007, again around 18 years ago. So there's plenty of opportunity to see a full moon when it happens. As they say, they cluster. So you can see the full moon with a bit gradually being chopped off until it becomes very reddish brown, and you see as the light is catching the top of it. Remember that, we'll see that again a bit later on. So Alison, obviously now Doctor of Astrophysics, she started off as a young observer. Astronomy can take you to great heights. She took around 100 photographs, and I always say how important it is to make a note of the time and the weather conditions. And I don't know what time this was taken, that's not there, but I do remember it being sort of late evening. Obviously it wasn't that cold. I don't know, it was a clear night obviously. We need that information, it does help. But it's a very nice sequence to show what is happening and what you may see. Here's a more complex diagram, and this shows the angle of sunlight, and using geometry with all these angles, how to prove that the shape of the shadow in an eclipse would always be a cone. And I put this in because it shows the application of geometry. And in my role as a STEM ambassador, I'm always promoting maths and science, and I find that a lot of people are put off maths because they don't know the application of it. There are lots of applications for maths, geometry in particular, in astronomy, and astronomy is a great subject because it encompasses everything from simply standing outside and looking and just enjoying the stars to understanding how and why things happen. So it's a great subject, and it's a great example to help people who are struggling with difficult concepts in these subjects. Back to that moon with the light catching on it, I said we'd come back to that. I made notes of my observations at the time. I was out and about at 7 in the morning, and although it was winter and it was cold anyway, it felt a different sort of chilliness that morning, and it felt autumnal. I've made a note that it felt autumnal, and that the moon was a sort of orangey pink in colour, with the features, the craters standing out really clearly. And John has shown this in his painting. He saw it, he observed it, made notes, and made a painting of it. And when I saw it, I said, oh, that's exactly like I saw. So because we both made a note of the time and the date and the weather conditions, we were able to confirm and verify that that was indeed what that eclipse looked like on that particular morning. And as an aside from that, this year's eclipse isn't at such a convenient time, and a few years ago I was observing an eclipse at 3 in the morning. It wasn't that cold. I was out on a sun lounger, and because the moon wasn't bright, there were lots of stars to see. I spent an hour or so out there, probably 2, enjoying it. Well, then I returned to bed to warm up. I hadn't realised how cold I was until I got back into bed. Then of course the alarm went off and I had a very difficult day at work. I was very, very tired. So plan these things carefully. Either have an afternoon nap, book the morning off, or just be aware that you will be tired if you're doing these things in the middle of the night. But it's worth it. It is all good fun. So tonight, this is more or less what the moon will look like, a waxing gibbous. It's getting bigger because we're heading to full moon on the 18th, and the eclipse is scheduled between sort of 12 and 6. You will see some action, with the peak being at 03:45. So again, not a particularly convenient time. It will be dark, it will be cold, but you will see, hopefully, if it's clear, the eclipse. So I mentioned the equinox in there because a few days after the 18th, of course, you've got autumn beginning, and that begins on Sunday the 22nd of September at 1:43 in the afternoon. So after Sunday lunch you can think we're now in autumn, and I always think it's nice to be aware of that. So going back to tonight, it's getting bigger, but it's not so full. So the lack of glare means more stars will be visible, which is great for observing craters along the terminator. So you can see you've got at the top, you've got the Bay of Rainbows, which is a nice wall at the edge of the Mare Iridium. You've got Copernicus crater in the middle, and Beladus further down, that clear one there. So 3 nice features to look out for in particular. Going back to eclipses, they do tend to cluster, and next year we've got 2 more in March and September, but then there's a gap because of this orbital tilt. The next one isn't until December 2028, sorry, December 2028. So make the most of this year and next year. Where will the moon be tonight? Should be visible above the trees, just. It's obviously quite low on the horizon because to get that angle of the full moon it's got to be opposite the sun, and to have an eclipse the earth has got to be in the way. So on the morning of the 18th it will be before sunrise, so the moon will be above the horizon but still quite low. And I've worked out that I might be able to see it from my bedroom window, because obviously the moon has got to be reasonably high because the sun is very low, it hasn't risen yet. So again, geometry and angles will help you work out how to see it from where you live or where you want to be that particular night. So best of luck in observing, and go outside and look up and enjoy the stars. Thank you.